Alright, time for another draftphysics.com, debatephysics.com, also video presentation. And yes, seeking some sort of counter argument provided in some sort of reasonably connected to the subject. It doesn't have to be necessarily polite, but it can't be overtly obnoxious. Anyway, yes, I'm making a claim that conventional physics is wrong. Got the wrong answers, and that the flaws are, kind of obvious. And it's just that they've never really considered their theory, okay, in any kind of depth. They just superficially liked it and then said, jumped aboard, and something like that anyway. Trivial things, you could argue that, okay, for the theory of bent space, the big event was the Eddington experiment, where they claim to have demonstrated that light is twice as bent by gravity. Now, even demonstrating that light is even bent by gravity is something, I would argue, because that hadn't even been proven yet, and let alone twice as much. So both are rather dramatically inconsistent with what can be understood is that we really couldn't crash photons into photons, can't really bend forces in any common everyday kind of way. It just doesn't happen. Force doesn't interact with force. It has to interact with matter, is what was observed, and so this was way out of place. Anyway, so that statement, okay, gave this theory credibility, but no one even really thought beyond that, and no one really tested it hard in terms of what it means. And so then they started thinking about it a little bit, and they started with this twin paradox because of the time dilation part, and found other instances, other ways you could think about it, and it wouldn't make any sense. It starts to fall apart a little bit. But what they never really considered is that this bent geodesic, this bending of warping of something that isn't a tangible or physical thing. I don't even know how to describe it, frankly. The whole idea that space is a something, okay, is a starting point. It's not saying there's a God, but it's almost like saying there is a Holy Ghost. And so it's an assertion, and it has to be made consistent with the evidence that exists. And so, anyway, so I'm just trying to, I'm cutting the mistake a little bit of slack and saying this is how you make mistakes, being more generous than I think science deserves, because, your whole job is to test it and test it hard. And because the only thing that gave them any reason to be lazy in testing is they didn't have a counter theory to compare it to. So it's really easy when you have some other theory to compare something to and say this theory is better than that theory. And they really didn't have any theory of gravity, because everything seemed to have a flaw. And what they weren't seeing was the flaws in their own bent space theory. So they could find the flaws in other theories, but they couldn't find the flaws in bent space. And there's really no excuse for that, because the flaw I'm going to talk about in this video is glaring. So, it goes right to the core of, any kind of rational understanding of things existing and non-existing. Okay, so leave us get to it. All right, so their argument is that what causes gravity is not a force. It's not a physical, energetic thing that makes things move. And right there you're saying, okay, but it does make things move, and that's the undeniable part. So something can be going about its business, and, you can't quite see it doing that. And gravity adds some velocity to it, and it crashes into the earth. Well, it's getting a portion of its velocity from the force of gravity. And the fact is that energy goes into the earth. And then on top of that, we know that the force of gravity always, when something's sitting on the surface, it's unfortunate. This pen just can't make it happen. It's very fancy, but yes, no ink. Anyway, so something sits on the surface of the earth, it's always applying a pressure. So there's always a momentum. So I could use the scale example and just kind of illustrate the point. Okay, which I have done over and over again. Found out where I hit it. That this constant pressure, I put something on here, it provides a constant pressure, has a constant pushing on the spring. And I could do the same thing this way, and you'd understand that the only way I could do that is that I'd have to have something hit it and keep hitting it and keep hitting it and keep hitting it and keep hitting it. That it's real momentum that's going in. So we know that, I know, that at 1 mile an hour I could throw anything at this scale and it will read its actual weight, okay, its gravitational weight. It'll read the same as it reads here, okay. So 1 mile an hour is essentially the momentum that something sits on the earth with. It's constantly applying that force, and it's real energy, it's real stuff. And so the idea is something sits on the earth and it applies this constant pressure, and something sits on this side of the earth and it applies this constant pressure, and so you have a tremendous amount of constant pressure in the center of the earth, where these two competing forces, because it's spherical and it's made spherical by this very force, is going to do its work. Now the other part that kind of gives it away that this is just about the matter in the earth, okay, is the fact that you could put a bunch of lead in a place on earth or some other heavy metals, and the gravity in that location will actually be higher. So if it's a bent geodesic, it's clearly seeing, okay, the density of the material in the earth. So the obvious argument I'm making is that it seems quite clear that what gravity is a differential between what would be equal forces if you were sitting in the universe. If I was sitting in the universe and there was nothing around me, I would have an equal amount of pressure essentially hitting me from all sides, an equal amount of cosmic background radiation, an equal amount of any kind of radiant noise. And the thing that changes when the Earth's in the way is that obviously the force that's going to hit me from the other side has to go through the Earth, and it takes time to do that. It takes time because it's going to hit a bunch of electrons and protons as it's going. It's going to move them a little bit, so a percentage of its voyage is going to be pushing electrons and protons, and they're going to move at a much slower speed, and so the force isn't going to get to the other side at the same time. And so there's always a deficit here, and that's what the spring sees. So when a spring is collecting your gravitational momentum, it's not quite in the picture. Okay, when a spring is collecting your gravitational momentum, what it's collecting is the differential, the fact that there's a lag between the force hitting you from the universe and the force coming up from the Earth, and you're stuck in that it hits first, gravity pushes first, and that the rebound shows up when a new first is already arrived. So the push, if you thought of the push as some kind of frequency, that the bent geodesic was creating some sort of infinitely high frequency, you could still understand that the push back always shows up too late. So it replies to the push that happened a moment ago. It doesn't apply to the push happening now. So you're always in a deficit in terms of you're pushed in first, and the push back shows up too late for the new push that comes in. It's always one push behind, you could argue. It's a simple way of understanding that. Alright, so the argument is, if I can keep the drawing clean this time, is that there's a bunch of energy going into the Earth. The center of the Earth gets really hot, which I guess I could try this. Molten, okay, and all of that happens because of the bent geodesic. All right, and that heat doesn't stay there. It's not an insulated Earth. It's not in a perfect, there's not perfect layers of insulation or something, so that heat is always radiating back out. So all the energy that goes into the Earth, that is all of this pressure, so the meteor strikes and all of the mass pushing in, constantly pushing in, constantly pushing in, it all radiates back, and that's the equilibrium that the Earth has to be at over time. So if we turned off the whole universe and just had the Earth with its molten center, very quickly it would radiate all of its heat and be some kind of 0 degrees, because the heat's going to travel out to the colder reality of the universe. So you'll see that it has a bunch of stored energy, and that stored energy represents the differential between the energy going in and the time that the energy will come out. All right, so that can sort of be understood. So you have a huge amount of energy here. I mean, it's, when you think about, well, and here's the thing to understand is that obviously this is the point where all the energy collides, so to speak, and it can't be destroyed. So the energy meeting this way and this way, for example, will end up going out this way and this way. Often collisions directly, you just look for a place where there's less pressure, and that's the direction that the energy will go in. So it finds a way out to start heading out. So it's heading in, collides, and then starts to head out. And the collisions can happen in all kinds of different places inside the Earth. It doesn't have to be in the center, but obviously the center is going to be the focus. Okay, that's where most of it's going to happen. So anyway, you have these layers of Earth that are thicker and thicker, bigger and bigger, because of the circumference gets bigger and bigger. It's much more mass. And so that's why the surface of the Earth, it doesn't reflect the high temperature of the center of the Earth, is because it's a lot more mass to heat. So the same pile of heat has to heat all the stuff going out, and as it gets to the surface, it's much cooler. But it's still hot. It's still a degree of heat. It might be minus 50 degrees, without sunlight. It might be a very low minus temperature Celsius, but Kelvin, in absolute temperature, it's still a very high temperature, hundreds of degrees Kelvin. And hundreds of degrees in Kelvin is still, when you think of the gigantic size of the Earth, even if the average temperature was 0 degrees Celsius, that's a huge amount of real temperature in terms of real motion of little bits of stuff. So bent space is obviously creating a huge amount of momentum in atoms, all these vibrations, all of this heat, and all of that turns into radiation out. So we know that it all radiates out as some form of infrared radiation, some form of something on the spectrum. And a lot of it can be on the spectrum that we can't see. And it's more likely that it's going to be microwaves and radio waves and infrared than it's going to be ultraviolet or any of the higher frequency, because it's gone through a lot of matter. Okay, and so if it had any high frequency, it lost it. So that would be a simple enough explanation. All right, so you have this problem of now you have a whole bunch of energy put into the universe, and it's essentially free energy if it was bent space, because there's nothing saying you used any energy from the universe to make bent space. The phenomenon of bent space is supposed to be without any force fueling it. And so the concept just loses all reasonableness, because you're creating a huge amount of energy into the universe. A huge temperature is being excreted by every large object in space, and it all was created by gravity. It wasn't something that actually came in besides just it being matter. Now, obviously, we have sunlight that comes from the sun, but it's a tiny amount of radiation when you add it up. I mean, you're talking about for a square meter, 1,000 watts. Not much. Clearly not enough to melt the center of the Earth or anything like that. So it's a minor amount, and that doesn't have anything to do with this. So it's really the universe itself that must be creating all this cosmic background radiation, this heat. And every bit of heat that radiates out of the Earth as it goes through space, it ends up hitting something else. And when it hits something else, what's it going to do? It's going to create that pressure. It's going to apply a momentum to that surface, and in the form of making an object like me push into the Earth. So the radiation is going to push me into some, if I was on another planet, it's going to push me into that planet, and it could be radiation that came from the Earth. So the universe is chock full of stuff. It's all radiating something, and that radiation is a sensible cycle. So you could just argue that the cycle, the completion of the picture, is that there's a bunch of other objects radiating, and those objects are doing the same thing the Earth is doing, and vice versa. And so the universe is at an equilibrium, but it's constantly applying pressure, creating this time deficit in the sense that the energy going in takes a while to come back out. So there's always this delay, which means that other matter will fall in and create pressure, okay, that has to wait to be equalized. And that's the engine. So bent space isn't a reasonable theory because it's basically a free energy theory. Because how do you take the heat coming off the Earth, in Kelvin temperature, and convert that into a bent space when the bent space is in a mechanism? And the clearly simple answer is you don't need to, because heat applies pressure. It is energy. The energy is what is pushing everything into the center of the Earth. It's being pushed in by a real force, by the fact that the universe in every location, if I just took a sample of the temperature of the universe at any location, it's going to have a temperature. It's going to have a bunch of radiation hitting that little point. And that temperature creates gravity, especially when you start adding more and more mass, okay, all pushing towards the center. It all ends up being a collection of momentum, and undeniably creating motion, and in turn creating the force that causes motion. You can't create motion without applying a force. So clearly bent space just breaks any kind of energy conservation or understanding of thermodynamic conservation, because it clearly creates heat, and then you have to account for the existence of that free heat, and that the universe would constantly get hotter and hotter if that heat wasn't being recycled to actually create the motion that created the heat. So the universe is just a big perpetual motion machine, okay? And the fact is it doesn't have any friction in it, and so it doesn't lose any energy. And this is all it does. It's just constantly compress matter, and then the matter expands. And as it expands and as it vibrates into the rest of the universe, it heats it. Let's see, what's a better way to say it? Look, the better way to say it is the simple truth is that there's force in the universe that's perpetually moving, and there's no other possibility except that stuff that's constantly moving is going to hit matter. When it hits matter, it's going to make it move. And if there's any place you can create a differential in that force, you're going to create motion in that direction. So the matter is just being jiggled around by the heat of the universe, and the matter itself forces there to be this there's only one conclusion. So you could go all the way back to, say, some sage, kind of a simplification of this argument, mechanical gravity, and just understand that if you did have a box, a container, and you filled it with just a bunch of little BBs, and the rule was they never lost motion, so they just bounced off the surface, kept their motion, so they were just constantly moving. And then you put two objects in there, two bigger objects, they will be forced together because they will shadow each other essentially from impacts. And so they will end up creating less force between them, less impacts, and there'll be more impacts on outside of them, and they will just be forced right into each other. So all you need is a universe full of energy, and you'll end up consolidating matter. And the trick is because of the nature of electrons and protons, that consolidation isn't unlimited. There's a certain size and amount of pressure you can create inside of something. It can only get so hot, and then it just explodes and you end up with a supernova. But the basic point is that clearly gravity creates momentum. The momentum creates heat. The heat is a real thing in the universe that has to be accounted for. So you have to have an explanation for how the heat disappears from the universe and turns into some kind of bent geodesic. And I argue there's no theory for that. And there's not going to be a rational way to fix the flaw in that theory, because bent space does in fact create motion. It causes it. And the emotion must come from using some energy, some force. And so bent space has to be a force, and bent space has to be a something, not a nothing. And it's not bent space. It's heat in the universe. That's what's causing gravity. The universe is hot, full of pressure. The universe is pressurized. Simple explanation. All right, I think that's probably enough. Okay, we'll call it enough. Well, I'll pause and see if it's enough. All right, we'll consider it enough. So bent space isn't a good theory. It's catastrophically flawed in terms of it meeting logical coherency. It doesn't fit with what we observe. What you can know is a fact. Gravity makes things hot. And you have to explain how the heat makes a bent geodesic.